All right, this is the second presentation of section 11.2, where we're trying to figure out the area of circles and related sectors. Now, the first day's presentation, I talked about this problem where Steve, Ashley, and Owen were going to try to build the tallest possible snowman. And Steve said, I should probably go as fewest number of spheres as I could make. And if I just do two, that'll make the tallest one. And Ashley said, no, 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 no. You want to make as many spheres as possible to make it taller? And she said she'd stack up 10. And then Owen was like, yeah, okay, you guys are both wrong. It doesn't matter. I can do as many as I want as long as I'm using the same amount of snowmen to make the same height snowmen. So I don't know if you spent much time thinking about this. I kind of hope you did. Do you know who's correct? Well, believe it or not, the person that's correct is Ashley. Because if you're making snowmen, you have the same amount of snow, and you go with just a couple circles of snow, you're wasting a lot of space that's going left and right because circles are all the way equally around. So the smaller number of snowballs that you make, the less space you're going to be wasting going side to side. So you'll actually be able to make a much taller snowman using more possible spheres. So Ashley is the one who's actually correct. So if you thought it was Ashley, good job. Well, let's take a look at another type problem that's kind of related to the snowman problem. Is I've got three circles here arranged as shown. I've got the green circle with a diameter of 20, and I've got a red circle with a diameter of 16, and a circle with a diameter of 12. And which color has the most area? So not necessarily what circle, but what color? Is there more green area here, or is there more red area between the two circles? So sometimes students will get kind of confused by the fact that there's some part that's sliced out here. So the red circle has lost part of this white part, and the green circle has also lost this part that's white. And same deal going on here is I've got a lost white part here between the green circle and the red circle. Believe it or not, you don't have to worry about these parts here because you're losing an equal amount of red as you're losing green. And again, over here, equal amount of red and green is being lost. Those are just going to cancel each other out. So in this case, you just basically have to figure out the areas of the circles and compare them. Now, there's another thing here. I kind of hope maybe you saw this, and there might be a couple of you that did, is that we've actually got, when we take a look at radii here, this radius is 6, this radius is 8, and this radius is 10. And that reminds me of a 6, 8, 10 triangle. So, believe it or not, if I take the 6 squared, actually the squareds are in the wrong spot here. It's kind of embarrassing. If I get rid of these squared, sorry about that. So if I take 6 squared and 8 squared, and that's going to end up equaling 10 squared. Sorry, the color's not right. Because one of the things you can do with this is you can divide all of these 3 by pi, and the pi's are going to go away. So 6 squared is 36, 8 squared is 64, and that's going to equal 10 squared, which is 100. So neither of them, the areas is actually between the two of them. The areas are the same between the red and the green. All right, so let's take a look at some more example problems. So last time we talked about how do you figure out the area of a circle, which is pi r squared. In order to figure out an area of a sector, you're going to take pi r squared and times the fraction of the circle that the sector is taking up. So a fraction of circle times pi r squared gives us the area of a sector. So I want to figure out the exact area of sector ADB. Now, don't get confused with this, okay? Sector ADB is not the red sector. Now, I know in the last presentation I told you for the most part we're going to be dealing with minor sectors, but in this case we're dealing with a major sector. So you want to make sure when you're looking at the name of that sector which one you're talking about. So sector ADB is actually the big sector. And that's going to be 300 over 360 degrees, because there's 360 degrees all the way around in a circle, and this white sector is taking up 300 of it, because if I take 360 minus 60, that leaves 300. So 300 divided by 360 is going to be 5/6. So first step, we're going to find the area of the circle. The radius is 8. 8 squared is 64, and 64 pi is the area of the entire circle. So 64 pi is the area of the entire circle. And then the big sector here is going to be 300 over 360, which is 5/6. So I just take 5/6 times 64 pi. So 5/6 times 64 pi is 320 pi over 6, which reduces to 160 pi over 3. So that's what the improper fraction is. You could turn that into a mixed number if you want, but I just left it as an improper fraction. All right, so here I want to figure out the area of the yellow sector, and the area of the purple sector, that's why this is in purple, is 38.51 centimeters squared. So the area of this part is 38.51 centimeters squared. Now, if you remember from yesterday's or the last presentation that you saw, whenever we're given an area of a sector, we always have to get the area of the circle. So the first thing before I even worry about what's going on with the rest of this problem is I'm going to figure out the area of the circle. So it's going to be fraction of circle over 360. So in this case, it's going to be 310 degrees over 360 times pi r squared equals 38.51. So that's going to look like this. So in order to solve this, I need to multiply by the reciprocal, or you can simplify this and go 31 over 36. But I'm going to multiply by the reciprocal, which would be 360 over 310, or if I simplified it, because I don't remember exactly until I moved the screen, if I made this 31 over 36, in which case then I'd multiply by 36 over 31 to isolate pi r squared and figure out the area of the circle. So that is in fact what I did. So I'm going to multiply by the reciprocal, multiply by 36 over 31 on both sides to clear this out and isolate my pi r squared. So when I do that, I end up getting as a total 44.7 for pi r squared. So that's the area of the entire circle. So now in order to figure out the area of the yellow sector, I'm just going to take the whole area of the circle, which is 44.7, and I'm going to subtract the purple area of the sector at 38.51, and that gives me a total of 6.21 centimeters squared. All right, so this is really similar to one of the last problems that was on the previous presentation, was find the area of the shaded part. So a lot of you may want to try to make this into one problem and just try to do this all as one big deal. But really, I think it's a lot easier to try to split at least these circles up into two separate circles and then combine them and then take care of the whole area. First thing I do is find the area of the rectangle. I'm not given the lengths here, but if this is 18 going from top to bottom, then from here to half of here is going to be 18, and then from here to here is going to be 18. So if I take 18 times 18 and 18, which is 36, I get 648 inches squared. And then I'm going to deal with each circle here separately. So each circle, because this is 18 all the way across as a diameter, the radius is going to be 9. And so the area of each circle is going to be 9 squared pi, which is going to be 81 pi. And then this one will also be 81 pi. So I can now combine these together into one thing. And 81 pi and 81 pi is 162 pi, which is 508.7 inches squared. And then I just have to subtract these. So if I subtract the area of the rectangle and subtract the circles, what's going to be left is the shaded part. So 648 minus 508 is going to be 139.3 inches squared. All right. Okay, so this is the last problem. So how much area do I have to paint on this wall? And you'll notice I'm not going to paint the door or this part going over the door, which I don't remember what that's called. Maybe it's a gable. Maybe I should call Mr. Bai and ask him. I bet you he would know because he knows stuff like this. He does home improvement, and I know he's done painting, so I know he would be able to answer that, but I think it's called a gable. So what do I want to do? So first thing I'm going to do is find the area of the whole wall. So kind of like the philosophy of the previous problem where I found the area of the rectangle and subtracted the areas of the circles. I'm going to find the area of this entire wall, and then I'm just going to subtract these two parts right here. So the area of the wall is going to be 36 times 26, which is going to be 936 feet squared. And then I need to take away the two parts. So I'm going to take away this door part, which if this is 16 feet going across, and from here to here is 16 feet, this is going to be 16 times 16 for the area of this square. And 16 times 16 is 256 feet squared. And then I got to figure out this, okay? So this is almost a circle. It's actually what we call a semicircle, so it's half a circle. But I can find the area of a whole circle and just cut that answer in half. So if this is 16 feet going all the way across, then the radius of this is going to be 8 feet. And so I'm just going to take 8 squared times pi, which is going to be 64. And then half of 64 is going to be 32. So the area of this semicircle here is going to be 32 pi, and that's 100.5 feet squared. So in order to figure out how much I have to paint, all I need to do is take my wall and subtract these two numbers from my wall, and that'll give me my answer. So that becomes then 579.5 feet squared. All right, so that finishes my second part of 11.2 presentation, and I hope you found it helpful. Thank you, and have a good rest of your day.